We're going to concentrate with the titration sort of. I'm saying stoichiometry. Also go to B first. Now, using 25 cubic centimeters of aqueous sodium hydroxide, 2,24 moles per cubic decimeters concentration, comma, and 3,86 crystals of were obtained. Calculate the percentage yield. So now they always help you to do step by step. So let's do step by step. Number of moles of hydroxide. So let's see, what are we given here? The volume and the concentration. Do you agree? And from what we said in your formula, in your book, C number of moles is concentration times volume. So in this case, it's 25, but it should be cubic decimeter divided by that, multiplied by the concentration 2,24. What do you get? What do you get?
Um, 0.056.
0.056
Yes, sir.
moles. Now, find the number of moles of the sodium sulfate hydrated with 10 water molecules. Now look at this. So the mass of, okay, I told you this. So now the next thing is the maximum, oh, I just skip that. Maximum number of moles of this. So I go back to my equation here. I've got sodium. So now let's look at this ratio here. This is 2:1. Can you see that?
Yes, sir.
So it means if I'm using 0.056, I'm only using half of that. We are using the balance equation. So half of that, how many moles do we have here?
0.028.
0.028. So this and that is 1:1. So it means the number of moles here is 0.028. Maybe?
Yes.
Now, mass of 1 mole, the moment they say mass of 1 mole, it means the MR. No need to calculate, it's clear. MR of this whole compound, they've given you, they don't want you to calculate. Maximum yield, so the maximum mass possible. It's the maximum number of moles multiplied. Remember, N is also equal to M over MR. So mass is equal to number of moles multiplied by MR. So in this case, it's 0.028 multiplied by 322. What do you get? Maximum possible. Theoretical mass.
9.016
grams. Now look at this. The percentage yield is the mass that we are actually obtaining in the experiment divided by the maximum possible, which we found 9.016 multiplied by 100.
Uh, 42.8.
Yeah, that's how we do that. I'll get all your 8 marks clear.
Yes, sir.
Now let's do this here. Write down the equation for the action of heat on zinc. So what you should remember from what we said last time is that zinc is always 2+. Hydroxide is always minus like this. So if this is as good as 1:2. So we need to, we cross multiply. We need 1 zinc. We always start with the metal and 2 hydroxides. So that's the formula. So zinc hydroxide, because without knowing that, then your formula, you write the wrong formula here. So we are heating this. So if we heat this, we form zinc oxide. Plus what? Plus what? Maybe this is a white oxide. Are we together? Now describe what happens to solid sodium hydroxide. Is like this group 1 was N plus or minus. So group 1 hydroxides, so it doesn't decompose. Huh? unfortunately. It's like this one here, because it's a very strong oxide. So it only melts for all group 1, only melts, but does not decompose. So it doesn't form any, remains clear, does not decompose. There's a strong bond, clear? Are we there?
Yes, sir.
Then what would happen when you hit nitrates? So there's one. So with nitrates here, group 2 and your other metals. So for most, if I want to say most metals, except for group 1. So group 1, the only metal that behaves in group 1 like all nitrates is lithium nitrate. Lithium nitrate. Sorry. Lithium nitrate is the only one that behaves like group 2 and other metals. Because in general, if I say a metal nitrate, if I hit it, I should form a metal oxide plus nitrogen dioxide plus oxygen. I form 3 things. So nitrate, this one does that, but the other group 1 metals don't behave like that. So now in terms of copper nitrate, going back to our formula here, remember, copper nitrate is 2+. That's why they told you this. Nitrate is simply like this. So I need 1 copper but 2 nitrates. So which means the formula is like this. Then when I hit it, remember I said copper, we form copper oxide. Copper is 2+, oxygen is 2-. So 2:2, 1:1. That's why it forms a formula like that. Plus nitrogen dioxide plus oxygen. Are we together? But now of course, this will help me to explain what would. Now, just we're just doing it this in terms of balancing. So the challenge is we've got 6 here, oxygens. We've got like 5 oxygens. So if I put 2 here and I put 2 like this, I now have 2 copper, 2 copper. But now nitrogens here is 2 nitrogen times 2, 4. So I need 4 here. So now if I do 4 nitrogens, how many oxygens do I now have? 2 oxygens, 8 oxygens, 10, 12 oxygens. Let's see here. 6 times 2, 12, balanced. So now this is so observations. They're saying what do you observe? So this is blue here, blue solid. That's the first observation. Blue solid tends to black oxide. Tends to a black oxide. Clear? Copper oxide, copper 2 oxide is always black. Then this gas here, you observe it because it's a brown gas. So you observe a black solid turning into a clear, a blue solid turning into a black solid, and a brown gas. This is colorless and odorless. You won't see anything. Clear? On the oxygen. Colorless and odorless, so you can't see an observation there. Are we together? And there's no water to say we can form bubbles. So no observation on that. Are we still together? You guys are quiet.
Yes, sir.
Now the next
Yes,
one. Iron 3 sulfate decomposes when heated. There. Calculate the mass of the iron 3 oxide formed and the volume of the sulfur trioxide produced when what? Mass and MR, mass of 1 mole MR. So number of moles we are now using, we can't use concentration here, we are using mass divided by MR. So what is the mass of the iron sulfate? 10. What is the MR? You don't need to calculate it. It's calculated for you 400. So what do you get? 0.8. Just check on the calculator. Is that correct?
Yes, sir.
Okay. Now, isn't this 1:1? 1 year, 1 year. So it means I should form the same number of moles. Epic. Now, the mass formed, remember, look at this formula here. Mass is equal to number of moles multiplied by the MR. So in this case, we want 0.025 multiplied by the MR of this. We don't have it. So let's use our periodic table. Iron 2, we have 2 ions, 3 oxygens. So 2 ions, what's the mass of iron in your periodic table? Quickly, mass of iron. Check your mass of iron. It will be 56 in your periodic table. Are you getting 56?
Yes, sir, it's 50.
What's the answer? Yes. So what's the total mass here?
It's 160.
So then we are saying that number of moles multiplied by 160. So what's 0.025 times 160? That's your answer here.
It's 4.
4 grams. Now, number of moles of sulfur trioxide, isn't this 1:3? We said 0.025, 0.025. So this is times 3, 1:3. Multiplied by 3 here, you should get 0.075. That making sense? We simply multiply by 3, 1:3. Happy?
Yes, sir.
Then the volume, remember what we said? We said to find the volume of any gas is number of moles multiplied by 24 cubic decimeters at room temperature, because 1 mole contains 24 cubic decimeters. So it's 0.025 times 24 cubic decimeters. What do you get?
One 1.8.
Yep. Calcium and other minerals are essential for health, teeth, and bones. The tablets are broken, are taken to provide these meals. How the bones? Okay. Boron is a non-metal with a macromolecular structure. What is the valence of boron? Can you go and look for boron in your periodic table? See which group it is. Valence means the number of electrons in the last year.
The valence is 3.
Yes, because valence is the number of electrons in the last year. If it's group 3, it means 3. Now, it's 5, 2, 3. So now, what are the physical properties we are guided by this here? Macromolecular structure. So physical properties, what do you think? Any physical properties? Macromolecular structure. Boron is a non-metal. So what are the physical structures? If it's a non-metal, any physical structures that you can think of?
The melting point is 2079 degrees
No,
Celsius.
we're supposed to just mention, we're not supposed to claim anything. To mention general properties.
Oh,
Why should it be claiming
it's
anything?
black.
Yeah, we are, remember, it's a general question here, if I can try to help you. So because it's macromolecular, I can say high what? High melting point, because it's macromolecular. Even though it's a non-metal, but it's a macromolecular, so it has high melting point and boiling point. So those are actually two different things, clear? You can get 2 marks for that, clear? Then because it's a non-metal, poor conductor of what? Of heat, yeah? Clear? Poor conductor of electricity. How do you get that? Then brittle, because it's non-metal. Non-metals are brittle. Clear? And dull surface, clear? It's metals that have got a shiny surface. So it's not ductile because it's a non-metal, clear? Not malleable, you see? That making sense now? It's not sonorous. It means it doesn't make sound when you hit it because it's a non-metal. That's what you're talking about. Are we together? Keyword here, non-metal and macromolecular. Macromolecular give us the high boiling point. Clear now? Name another element and compound that is a macromolecular. So we know that diamond is a form of carbon or graphite. That is clear. Then the compound, we can talk of silicon oxide. Are we together? Then diamond has got is bonded. Every carbon in diamond is bonded to other 4 by covalent bonds, but strong covalent bonds. So by this here, I mean, remember, diamond has got 4 electrons in the last shell. So it means there is no lone pair of electrons here. So this is a strong covalent bond, then it forms a lattice structure like this. So that's your diamond here, macromolecular structure. If it was graphite is only every carbon to 3. So because of every carbon to 3, what it means is you've got a lone pair of electrons here. So imagine if you've got a structure joined like that, so you've got a sea of delocalized electrons. It's there, the proper diagram in your book. Sea of delocalized in your complete chemistry. That's I said you should be reading. Sea of delocalized electrons. So it makes graphite what? Slippery. Clear? And it also makes graphite soft and be able to conduct electricity. Unlike diamond, conduct electricity because of the sea of delocalized electrons. Here, there's no delocalized electron, carbon, diamond, but diamond has got very long because because diamond is actually hard and has got a higher boiling point and melting point than graphite. Are we together? Diamond and graphite. Describe reactions, if any, if we react. So this is testing for ions. We're testing for zinc 2+. We're testing for copper 2+. Maybe I've given it there, but anyway, we'll look at it again. So if I add sodium to zinc ions, I form a white precipitate, which dissolves in excess. Copper ions always form blue precipitate. But the difference with if I'm using ammonia here, ammonia dissolves the copper, the blue precipitate dissolves in excess. But if it's sodium hydroxide, is blue precipitate does not dissolve in excess. Clear? Does not dissolve in excess. But if you put it in excess ammonia, it becomes deep blue. It dissolves deep blue solution. So it does not dissolve in excess. Are we together? Oh, sorry. This is the answer for, oh my gosh. I'm writing answers on the wrong things. So anyway, out there you simply say white precipitate, clear? Then there you say does not dissolve in excess. It means it remains a whiter, does not dissolve in excess. Are we together? So the precipitate
Yes,
together.
sir.
Then the blue precipitate does not dissolve in excess. Sorry, mixing things. I gave you the correct things. Why I quite dissolves in excess. Yeah, the zinc dissolves in excess to form colorless solution. Morning, morning.
Morning, Mr. Chota. How are you?
I'm good.
Yeah, we have got a challenge. Our cell Wi-Fi is down.
Oh, I see.
Yeah.
So I'm recording the lesson.
Oh, okay, thank you.
Okay, okay.
All right.
Okay, sorry for that. Does not dissolve in excess. Are we together now? Happy? Confirm our next lesson is after lunch, if I'm correct. I think I got A level after
Yes,
this.
it's after.
Okay. Nice, I think. You submitted your mess, I'll mark it. So now, next one. Each tablet contains the same number of moles. We're given the question. Now calculate the how many moles of whatever were in one tablet. So what's the first thing? Number of moles of carbon dioxide. We are given the volume. We said 1 mole contains 24 cubic decimeter. So now if you want to calculate the number of moles here, it's simply the volume divided by 24 cubic decimeters. That's what we said last time. So if you do that, you should get 0.01. That's the number of moles of the clear. So it means we are producing 0.01. We should be using 0.01. Why? 1 is to 1. Clear. Happy? Then if this is 0.01, then this is also should be 0.01. Can you see that? You guys are very quiet. Then the number of moles of calcium carbonate and this, so 0.01 plus 0.01. So this is, it gives you 0.02 here. And the number of moles of the carbonate, we said 0.01. Happy? Now use your answer in whatever. So calculate the volume of the so now we are using N is equal to C times V. Then volume is equal to number of moles divided by concentration. So let's look at the hydrochloric. Can you see that it's 1 is to 2 here? So it should be 0.02. So we're saying number of moles 0.02 divided by the concentration, which is 1 here. So it remains 0.02 cubic decimeters. The volume. Clear? Oh, I was too quick anyway, but that's the actual answer. But anyway, let me do it in stages. I didn't see that. So number of moles we talked about, and so this here we said 0.02. But then we calculated together. We said 0.02 divided by 1. So it gives you 0.02 cubic decimeters. If we want, it's 0.02 multiplied by 1,000, it gives you 20 cubic centimeters. Or you can leave it as 0.02 cubic decimeters. Clear? That's the volume. Are we still together? So far, we haven't done it. We'll do the topic on sulfuric acid and sulfur. Now I'll go to the stoichiometry, the last section for the day. So now calculate the mass of this sulfuric sulfur chloride formed by this mixture. So formed by the mixture, let's see what we are given. 8 grams of sulfur dioxide is mixed with how many grams of that? So calculate the number of moles of the sulfur dioxide. We now know the formula. We are using N is equal to mass divided by MR. So what is the mass we used? 8. So can we calculate the MR of sulfur dioxide quickly? Calculate the MR. Give me the correct MR. Use your periodic table of the sulfur dioxide. Was want to divide it here. 8 divided by the MR. Can you give me calculate quickly? MR of sulfur dioxide.
$64.
Let's see, I think it's correct. 2 plus that, yeah, 64. So 8 divided by 64 is 0,
125.
okay. Now we use 32 point whatever of chlorine. So 32, so 4,2 divided by. Now can you calculate the MR of chlorine here? It's 2 of that. Multiply the mass of chlorine times 2. What do you get? Should be 71. 35,5. Is that correct?
Yeah,
Times
71.
So what's 14,2 divided by 71?
71. 0.2.
0,2. Now listen very carefully. This is 1:1. So if we should be using the same number of moles, but we are having more moles of chlorine. So which one is in excess straight away? Chlorine, because we should be using also 0,05. So chlorine is in excess. Then what it means is sulfur dioxide is the limiting factor, because it's the one limiting our what? Our reaction. Is that making sense? Now, when they say how many moles of this were formed, we can only form because this is too much. This is okay here. So we can only use the one that is the limiting factor. So 0,025, this is restricted to 0,025 because it's 1:1. Then there we also form 0,125 because it's 1:1. Clear? So we only form 0,125. I hope it made sense.
Okay. Yes.
Okay.
Oh, wait, so here it says which region was not in excess. So
Oh,
it's
sorry.
the
Opposite.
sulfur dioxide.
Sulfur dioxide.
Mhm.
So now calculate the mass. Now we want the mass of this. So we now have the moles. So it means we have to calculate the MR of this. So let's think of, because the mass here has to be the number of moles times the MR, as we said, playing around with the formula. So let's calculate. Can you quickly calculate the use your periodic table? No, I think this is 71. Or you said this is 64, so it's actually easier because we are just combining this. 64 plus 71. But anyway, you can use your 32 plus 16 times 2.
It's 135.
100. Oh, it's given here. We didn't even, so there was no need to calculate it. So 0,125 times the 135. What do you get?
0.125 times 135. 16.875.
Yeah. Done. Well, I should give you an exercise homework on these calculations. Huh? Okay. We'll see you after lunch.
Thank you, sir.
You're welcome.